let f of x equal 1/2 e to the negative x over 2 as long as x is greater than or equal to 0, and then the function is 0 as long as x is less than 0. We're told that this is a probability density function, and conveniently we're told that the mean is 2. And we're asked to find the value of the standard deviation. The symbol is sigma. So in order to find the value of the standard deviation, we first need a quantity called the variance. The variance is a number that is used to measure spread. It measures how far the data points are away from the center, essentially. It takes into account the probability as well. So it's called sigma squared, and it's found by integrating from -infinity to infinity x minus the mean quantity squared. It gets squared because if you just do x minus the mean, the nature of the center would basically make everything add up to 0. And so by squaring, that takes care of that. Some values are below the mean, some values are above the mean, and so we just deal with the distance from the mean squared. But then that issues a problem because then we have units that are squared, and so variance isn't a great measure of spread. A better measurement of spread is called the standard deviation, where you get the units back into the correct values because you take the square root. So first our job will be to find the variance, and then after that we'll take the square root, and that value will be called the standard deviation. Okay, our mean is 2, so we can plug that in. And so sigma squared is going to equal the integral from -infinity to infinity x minus 2 quantity squared times our function f of x, which is 1/2 e to the negative x over 2. I'll just put the half in front. In fact, eventually I'm going to pull that half all the way out. Remember the function, though. It's 0 for everything less than 0. And so we can do this only because the function is dead up to 0. And then after 0 it becomes alive, and it becomes that function there. All right, great. So we need to recognize that it's improper. This because it has the infinite upper limit. Introduce a limit to handle this. So let t go off to infinity. And we need to integrate. What technique will we use? Integration by parts again. But this time we'll employ the shortcut, because if we don't, we'll have integration by parts twice, and it can be a bit messy. So we have to be careful here, but we're going to do it. On the other side here, we're going to differentiate the polynomial part down to 0. Let's keep the half in there. Differentiate this down to 0. The other guy, the exponential part, will integrate the same amount of times. So the first time you take the derivative, the 2 and the half cancel each other out, and you have x minus 2 to the first power. Chain rule just gives you a 1 by multiplying by the derivative inside. So the first derivative is x minus 2. The next derivative of that, it would be 1, and then the derivative of that would be 0. So you took the derivative of the polynomial term down to 0. How do you know when you can use the shortcut? When you have a polynomial term times an exponential term, or a polynomial term times sine or cosine. How does this shortcut work? Well, then you take the other part, the exponential part, and you take the integral of it the same amount of times. Remember how we do the integral of e to the kx? We get 1 over k e to the kx, with our value of k being -1/2. So 1 over -1/2 is a -2, then another -2, then another -2. So that's how we end up with the first time through getting us -2 e to the next negative x over 2. And then we get a +4 e to the negative x over 2. And then a -8 e to the negative x over 2. This shortcut is a tool to help us get the antiderivative quickly. The next step in the process of the shortcut is to multiply along diagonals going down and to the right But to get uv minus the integral of v du to work out, what we need is alternating signs. Employ alternating signs, and we'll start with plus. So the antiderivative will be us then multiplying the 1/2 and this 2 cancel each other out. So we end up with negative x minus 2 quantity squared e to the negative x over 2. Then we get negative 4 x minus 2 quantity times e to the negative x over 2. And then we get negative 8 e to the negative x over 2 because it's just times 1. And what we can do is factor out this e to the negative x over 2. It's in every term. When we factor it out, we'll be left with the other terms that are here. And because it's e to the negative x over 2, what we can do then is put it in the denominator as e to the x over 2. It just makes things easier to deal with when you have only one fraction. That's a recommendation that I make for you. Okay, so we go back, and we now look at the limits of integration being t and 0, and we plug them in. Put a t in every place you see an x, and then put a 0 in every place you see an x. Okay. What happens here? Well, we get 0 minus 2, it's negative 2. Negative 2 squared is a 4. So this here is a 4, but it's a negative on the outside. This guy is a positive 8, and then we take away 8. These guys cancel out. E to the 0 is a 1. So that part will combine to be a positive 4. The negative here and the negative here can't balance out to give you a positive 4. And now we can focus our attention on this part here with the t and evaluate the limit on that. Let's do it on the next slide. The original problem, the limit we're currently looking at, and now we're going to find this limit by trying to conceive of what happens as x gets very big, and once again we'll be in the format of negative infinity over infinity, because a big number minus 2 is still large. Large number squared is still quite large, and then we throw a negative on it, and so we'll end up with another negative here because it's negative 4 times a large number. Anyway, this is ready for L'Hopital's rule. How does L'Hopital's rule work? You can take the derivative of the numerator. Now be careful here. If your function is negative t quantity t minus 2 squared, negative 4 quantity t minus 2 minus 8, what's your derivative? You bring down the negative 2 and you take t minus 2 to the 1. Derivative of the inside is 1. Then here you're going to get a minus 4. If you want to, you can distribute this out and get minus 4t plus 8, and then there's a minus 8. Those guys go away anyway. I'm going to leave them in there though. And so we end up with negative 2 times the quantity of t minus 2, take away 4 as your derivative of your numerator. Your denominator derivative is this same guy again, e to the t over 2, but then chain rule says multiply by the derivative of the exponent, so we multiply by a half. And we consider this as t gets big again, and we'll be back in the negative infinity over infinity form. But we made progress because we had it as a t squared, now we have it as a t. One more time through using L'Hopital's rule, we'll be in good shape because our derivative ends up as a negative 2 in the numerator, and in the denominator we get another factor of a half to give us 1/4 e to the t over 2, and as t gets big, e will get big, and negative 2 divided by a very large number is a small number. We say all that to say that the integral is 0. I mean the limit is 0, sorry, not the integral. The limit is 0. What's the integral? The integral is that 0 that we got plus a 4. That's what sigma squared is. Sigma squared is 4. It's called the variance. We need that in order to get the standard deviation, and we take the square root. So it turns out that the square root of the 4 here. Standard deviation is always positive square root. And so we end up with 2 as our answer for the standard deviation.